All right, as Masashi mentioned before, one of the big wins when you're dealing with microservices, and a big reason for people going to microservices is the DevOps experience. Now, it's not a little bit orthogonal, but if you have microservices, that enables you to do very interesting things in DevOps. If you decompose things, then you have the ability to deploy them a lot faster independently, scale them faster independently. So it really changes the game potentially. So here we're going to talk about microservices versus monolith, the classical comparison. CI/CD. Now the CD in this case is the continuous deployment. Oftentimes people confuse that with continuous delivery. I'll actually be talking about the delivery part. That's a typo, actually. I'll be talking about monitoring, and I'll be giving some demos, right? So the value prop for microservices, again, you've got the individual team picking their own technologies, their own stacks, whatever is best for them. You've got a fast release cycle. You have the ability to scale independently. That's all great stuff, right? Everybody likes that stuff? Yeah? Yeah? It's all great stuff. Now with microservices, done. Well, what does that mean to the DevOps team or the ops side of the team? It's not so happy. Like, how do I do this? It's a lot to ask for. Got a lot more moving pieces now. You don't just have one release pipeline, you have N release pipelines. How do you deal with this? Right? It doesn't just happen automatically. Oftentimes you need a CI/CD process that is mature. You can't just deploy to production anytime you want, can you? I mean, that's the sales pitch. You can deploy to production immediately. You can go 20 times a day. Do you trust your code going to production 20 times a day? You have to have a mature process. If you've got automated tests that will guarantee that your system is running as you expect it to, yeah, okay, I could see those tests being run multiple times a day and your code going to production many times a day. If you do not, then you may have to do some manual aspects, and so you may have to scale back. So the continuous deployment side is that last step, getting it to production automatically. We're going to talk about more of the delivery parts. Okay? Yep. So you got continuous integration and continuous delivery. We'll talk about the integration piece first, but here's the high-level code flow. So the developer goes and merges code into a Git repository that will trigger build server, creates images. The images will get pushed out into your production by Kubernetes. Okay? Now, CI. So developer writes code, fixes bugs into their own feature branch. They go ahead and do all the tests they can do locally, right? Run their unit tests. They may do Docker Compose up in order to see all the containers talking to each other on their own box. Then they may also deploy that into Minikube so they can see the like the local version of an orchestrator running with those services. If that's all good, next step. Developer pushes the feature branch to origin. So now the build server can see that. Build server sees that, goes and runs the same test that was running locally, the unit test, integration test, and if those all go well, then it goes ahead and creates an image. Right? And it tags that image with the build number. That's really important. And pushes the Docker image to repository. Right? Everyone agree with this? Any challenges? Yeah, that's the same as your process? Pretty close? Yeah. All right. So now the continuous delivery part is a little bit different. So assuming that you have a happy CI experience, the build server deploys the image to some sort of integration test environment where we can do the integration test. Now, what is that test? what is that environment compared to my local environment? My local environment, I oftentimes will have my tests being run against mocks. So I have latest of my code, but I want my mocks in order to throw some certain exceptions or return certain error codes to see how my code responds to that. So that's more my dev experience. I want to make sure my code runs well under certain really controlled experiences, controlled environments, right? But in the integration test, we want the live code. So the same code that's in production, as Masashi mentioned, A sent an update and it conflicts with C. Well, how are we going to know that? Well, you'll know that here in your integration test cluster, because I'll have my new code, my code that I'm hoping to put in production, but we actually will have the live code of everyone else. So I'll see all those integration errors here in the stage. Well, at stage number 2. I'll run the end-to-end integration test, and if for some reason they change their API, breaking change, and I didn't adjust for it, boom, it should fail at that point. Okay? The build server can deploy that to a perf and stress. Perf and stress test run. Now, this step 3 and 4, that's oftentimes where the maturity of your systems differ. How many people have automated perf and stress? 1, 2, 3. You people are rock stars. Right? It's very rare to have that level of maturity. If you have that level of maturity, then yeah, I can see that if it passes the integration as well as your perf and stress, I can see that go into production. I might go ahead and bless that. Go for it. But if you don't, then this step over here, 3 and 4, may have to be manual. So that just slows down your deployment pipeline. Okay. Now the build server can deploy the image, assuming that it passes all those tests up to 4. We're now in step 5. It can go and deploy that to your production environment in several different ways. Let's say that you have a small fix. No breaking changes, just a patch. The question is around code coverage. What kind of code coverage do you expect? That's something that you have to decide as a team, right? So if you want your build to be dependent on code coverage, then you have to decide what you really care about. Code coverage is just a metric, right? You could have a high percentage or low percentage, and they could lie. You could have a whole bunch of markup. Do you care about that? That's going to affect your code coverage. I would say you want to look at the bang for the buck. The code that you really care about testing, you want to have high code coverage on that. And if that starts to slip, that gets below 80, 70, 60, that would be a warning. I might break the build because of that. If you have a whole bunch of markup, I don't care. That's UI. I don't care. So that is a number that you have to figure out as a team. Okay. Question over here? Sure. The question is around testing in production. And I think you see that sometimes with A/B testing. You might send a certain percentage of your user to a certain version of your software. Maybe it works, maybe it doesn't, maybe it has some errors. So that's one way to look at it. The blue-green is one way of doing it. You could test, for example, you could have your version 1 in production. All the traffic is hitting that. And then you could have version 2 sitting there, like some components of version 2. You can maybe put a cookie in the request and have your requests of your test users go through that. That's one way of looking at it. But yeah, thanks for the question. Did I answer? You had more of a comment, really. Okay. All right. So getting back to the deployment to production. So if you have a patch, oftentimes what I've seen is you would use the Kubernetes rolling update for that. So getting back to the Service Fabric question, Service Fabric does that very, very well. The rolling updates is very easily done. in this case, what we're saying with the blue-green is that if you have a breaking change, you have something that really, you don't want the old version talking to the new version. It's just really complex. You just want kind of an all or nothing type of experience. I would go ahead and do the blue-green. So you have version 1, getting all the traffic. You deploy version 2 there. You can even do some smoke testing. Right, put the cookie there, make sure all paths work. If that's good, flip all the traffic to your version 2. If that goes well, then you stay on version 2. You start scaling back version 1. If it doesn't go well, flip back to 1. So that's your typical blue-green deployment. Again, that's for your breaking changes and your major updates for blue-green. Right? So, pro tip, the latest image tag, so I talked about image containers or Docker images. What is an image tag? Anybody? Anybody? It's a version of the image, exactly. So when you push an update to your container repository of your code, of your image, I've got a new version, you can push it up there and say, here you go. And then it'll say, oh, well, here's the latest. So it has a default tag called latest. And then you can say to Kubernetes, hey, go get the latest. Well, there's this thing called caching. It's a wonderful thing. Sometimes it doesn't work as you expect, right? So you could have one of your nodes go and get latest, but you could say, oh, wait, I already have latest. There you go. Let's go and put that in production. All of a sudden, you've got some nodes running the latest, and you got another version of the latest running on other nodes. Very hard to figure out what's going on. Very hard. So don't use the latest image tag, use a specific version. So when you give a version number to your images, use something like the build number or the commit, abbreviation of the commit that was used into master for that. So that's a good way to relate back to your code what is in that image, right? But this has bitten a lot of people. So just don't assume that latest will give you the one you're looking for. Okay? Any questions about that? Yeah? All right, monitoring. Again, do you have the full picture of what's going on in your system? Do you know what's going on? If something were to hiccup, something were to fail, do you know? Do you care? You probably care. Most people just don't know. Okay? The monolithic experience. You've got an app, but it's different components, but you probably are using the same logging tools, the same monitoring tools. You may have some governance saying, hey, everybody needs to do this way. So there's typically a lot of consistency in that experience, isn't there? All right, all your data is going to the same sinks. It's going to one sink right here, right? It's very well known. It's relatively easy to monitor if you go ahead and put in those log statements and check the metrics that you should be checking. But in the world of microservices or distributed apps, it's a little different. Anybody see any problems here? Any problems? This is better, right? This is much better, right? Well, it's not much better in the monitoring standpoint because your data, your metrics, your logs are all in different places. Where do you go to find out what happened? So Masashi mentioned there's no governance. Is that a good thing? Let's walk back just a step. There's got to be some governance. There's got to be some consistency so that I can talk to these systems and say, hey, I want to know what happened. I've got a correlation ID. I need to find out what happened related to this correlation ID. I need to be able to do that. That's a question that your bosses will be asking you. You got to be able to answer. What happened? And you need to be able to relate the data. Back here, it was pretty easy, and everybody was logging the same way, so you could. There was a lot more consistency. Over here, it's a new world. Okay, so monitoring. The drone delivery was monitoring in many different ways. Metrics over here were collected by Kubernetes, system level metrics, CPU, threads, memory, that kind of stuff, right? What resource usage is going on in my nodes? So we're getting that from Kubernetes and put into Prometheus. So that's kind of time series type data. So Prometheus is a good option for the time series type data. Linkerd is handling all of the service communication. So since it's doing the service communication, it can know what calls what and how long it took to call that. So it can gather data too. And that time series information can also go into Prometheus. Or other stores. We found that Prometheus was a good fit in our case. Also, the log type information we're capturing. We're using Fluentd to capture the log information, passing that to Elasticsearch, and then everything is being visualized by Grafana. Right? Any questions about those options? Great question. The question is, how do I correlate? Right? How do I correlate all the calls from all these different services, right? Did I get your questions right? Right. Thank you so much. I'll pay you later. I'll be talking about that next. Okay. So let's talk about the type of data that we're capturing. We're capturing metrics, and we're talking about text-based logs. Metrics are numbers, right? You can average them, you can sum them, standard deviation, that kind of stuff. System metrics, what's going on in the box? CPU percentage and so forth. That's again captured by Kubernetes and just provided. Actually, Prometheus is scraping that information. Application metrics, inbound requests, queue length, latency of the application. That's being captured by Linkerd because it's a service mesh. It's knowing all the service calls. It can capture that, also send that time series information to Prometheus, as I described before. Application traces, like spans, right? I call A does some processing, A calls B does some processing, B calls C. And so all those execution calls are spans of time. And so those spans can give you a tree of spans, and you can see what's going on in your application. That oftentimes is visualized best in Zipkin. That's made for that type of visualization of spans. Okay. So what if your application calls an external service? SQL Azure, CosmoDB. We won't be able to track that in our system. So you would want to use something like Azure Monitor to be able to get the metrics into those systems. Okay. Now let's talk about text-based logs. Getting to your question back there about how do you correlate that information. Great question. I spent a lot of time personally on designing how we do this here. And it was really learning how people do it commonly, really. Basically, you have application logs. So your app writes, right? You've got ilogger.loginfo, right? Those types of trace statements. You also have the web server. The web server calls ilogger. So there's lots of logs being captured, right? So we need to somehow make sense of them and say, well, these are related to a certain order so that we can ask it. So what we're doing in the container world is using kind of the lowest common denominator. We're using standard out and standard error. That's what we use. That's what we're writing to. Everything just writes to standard out and standard error. The container file system, or kubelet, will listen to standard out and standard error and write those messages to the file system. Fluentd, if you deploy that as a daemon set, in this case it's one per node as a daemon set. it will listen to all the traffic coming into those text logs that are being written to the file system, and it'll send them off somewhere. It's up to you where you send it off to, but we've got configured to send to Elasticsearch. Okay? Any questions about this so far? Any challenges to that? Yes. So the question is about how people typically configure their Elasticsearch. So you have what? So do you split up the indexes? Do you have one index per microservice? Do you split it up? I don't know the answer to that. I'm not sure what people do commonly. I've just found out what we've done personally. And the index, we let FluentD decide that by default. What it does is create a different index per day. Really, it's a time-based index. And so that seemed to work for us. I'm not sure if people do it differently, but I've seen the model that we use quite often. I've seen a lot of people do that too. But yeah, that's a good question. I'm not sure.
Indexing by service doesn't make a lot of sense because we have to correlate the log across multiple services, right? So typically we index every day or even shorter, depending on the amount of logs.
Did that answer your question? Okay, all right. So I'll get to your correlation question very soon. Right, so let's see a demo of some system and type metrics. There it goes. So you can see here, we've got Grafana, and we're looking at the system metrics. In this case, we can just hover over here and you can see what's going on. In this case, we don't have a ton of traffic, but you can see one of the nodes has got 20%, all the rest are pretty quiet. Right now, we're not in the middle of a load test, so we don't have much traffic going on. But you can see that there's different load based upon the different nodes. You can see the memory also. There's some that have more than others. Oftentimes, this is due to different services that are running on different nodes. So if you have one that's really, really hot, your ops people will want to be monitoring this and be able to deal with that. They may maybe kill it and let the orchestrator regenerate that somewhere else so that it doesn't put so much demand on the resources of one specific node, kind of redistribute, right? So that is system metrics. Let's go to service metrics. So I want to see the metrics on a specific service. There you go. So there's a load done yesterday. Let me take a look at this. So you can see some top end, right? So this is aggregate type data. You can see the different percentage of success by different services, request volumes, and latency as an aggregate. But the important thing I want to show you is right here. Look at this. Okay. If you're not getting this level of statistics, you should be. You should be asking for it. You should be demanding it. Look at this. P95. 95% of the requests are handled within 50 milliseconds. That's pretty good, right? Done. I'm happy. I'm happy. But what about the last 5%? Well, sucks to be them, right? Sorry. Well, look, 99%. Well, 99% of the people are pretty happy. 600 milliseconds, it's okay. But what about the last 1%? Wow. That's an error. That's a timeout. This is going to wait. Very few processors are going to wait for over 3 seconds for that response. That's going to be an error. That might, if you didn't have any retry, that means a phone call. Hey, my order went dead. Help me. Right? If you're not getting this type of data, then you should be. If your system is only giving you average data over the last 20 seconds or so and only giving you average latency and not this type of data, what is it going to say? What is it going to tell you? It's going to say, oh, we're around 100 milliseconds. It's all good. Nice smooth curve, right? The devil is in the details. This is unhappy users right here. If you're not seeing this, you're not seeing your unhappy users. Are you not getting unhappy users? Oh yeah, you are. You just don't see it in your metrics. Okay? Any questions about that? Okay. Oops. Okay. Back to distributed tracing and logging. Now we're getting closer to the correlation ID. Almost there. So how do we get the type of data that we want if we want to see an end-to-end experience? What it showed you was aggregate data and then data about a specific service. So the account service had some problems. What does that mean for all of them? As in, some requests came in. The account service went slow, other services went slow. What's the deal with that? Right? How do I follow that trace? How do I follow that whole flow? Well, the way to follow it is by working with Service Mesh to track that data. When you're using Service Mesh, what will happen is that you hit an ingress point. Service Mesh will see that as a request that has not been, it's going to be a new request. And it's going to start adding certain headers to that request, context headers. And it's your job as developers of the services to propagate those context headers. As you can see here, you got some context headers. Now in this case, you've got some queuing, some messaging. So you actually have to take those context headers out, put it into your message that you put into your messaging system, and then retrieve it on the other end. Okay? If this was making a direct call like HTTP traffic, you could just go ahead and add that. As you can see here, service A is calling B with just an HTTP request. So you can add them as the request headers, which is how it came to you. So if you're using Service Mesh, the first request into your service here will get those headers. So you have to pass those context headers. That's your job. You have to propagate them down. Now, when you get to this point, you're not going to be able to propagate them, maybe because you're dealing with a client library or so, and this system may not, well, at this point, they don't care about those headers. Logging. This is back to your question for the gentleman in the back. One of these headers will have a notion of a correlation ID. It's the ID that is going to be common through the whole thing. So you need to take that out and use it when you log. So all your log statements have to be decorated with that correlation ID. Make sense? Yeah? So each one of the services is responsible for not only propagating the context headers, but when it logs, it has to log the correlation ID. Is it clear how you do that? No? Anybody done that before? Anybody? Oh, you've done it. Excellent. We got 4 or 5 people. Excellent. How did you do it? Okay. So you generated your own IDs. Yeah. Yeah. Okay. Thank you. Yeah. Thank you. Yeah. This is yeah. Yeah, this is a very common pattern. Yeah, you have to propagate those correlation headers, as we mentioned, and then you have to log it down here. The logging part is a little bit different. Not a lot of people do this, but in order to be able to correlate your logs, there's no other way. Otherwise, you'll get logs, you know, the account service logged, this service logged, other service, they all logged, but there's no way to connect them together, right? You have to be able to correlate them. So you have to log with the correlation ID. So again, the end-to-end correlation, the service mesh adds the context headers, and for for linker D, it's the L5D, which is linker D. Anybody know that? Anyway, yeah, it's L5D-CTX. So if you examine the request, you'll have headers, and it'll have like 7 or 8 headers that linker D will just add to you. You have to take that out and pass them on. When you call somebody else down line, you have to take those headers and you have to add them on, right? Okay. So what if you don't have access to the HTTP headers? Let's say instead of you're making an HTTP call, you're actually using a library, like document client. In that case, you have no access. You don't know what it's doing. It's kind of a black box. So in that case, I would just make sure you have logging statements before and after your calls. So at least you have some idea when your calls went out and if they're coming back, okay? So, correlation. As we mentioned before, you have to have some agreement, some governance. And in this case, we're saying you have to agree what to call, what field spelling, how you're going to save that correlation ID into your logs. My team just decided we're going to call it, quote, correlation ID. So you have to email everyone, when you log, you got to use, quote, correlation ID. Okay? And when you log in the logs, that way when we ask system, for example, Elasticsearch, we know what field to use. Okay? In the case of Istio, this was the one I found that was a best representation of a correlation ID, the trace ID. Okay? So what you do is you grab it out of the context header and you log with it. Right? And we said that when you log to standard out or standard error, you have to use a JSON format. So you take the value, create the JSON, and you have to then enrich it, enrich the logs. So when you use a framework, for example, Application Insights or Serilog, you can have it enrich logs for you. So imagine all your log statements, right? ilogger.log info.log warning and so forth. You don't want to go and add an extra value in each log call, right? That would destroy the readability of your own code. And every time you have to go and pull it out of the request and put it in there, that would be terrible. So what you do is you do it in a central place. So for App Insights, you use the telemetry initializer. What happens is that every log event that goes through your system, it can take it and enrich it. You can add more metadata to that log piece of information. That's what we're talking about. We want to decorate it. We want to enrich it with the correlation ID. Same thing in the case of Serilog. You create a log event enricher to add more values to your log. Okay, so just for your information, if you're using ASP.NET Core, which you have to use if you're trying to do ASP.NET in containers, the HTTP context.current static property is no longer available. You have to get an instance of the HTTP context accessor in order to get the HTTP context, right? Does that answer your question back there? Yeah? All right. So that's how you do it. This is an example of what Zipkin looks like. As you can see, this is a request for the hello service. It's a GET request. So the hello service is receiving it, and it makes a GET request to the world service. You can see all these spans are all, there's time related to each one of these span calls. And the parent one is the biggest one. So you're really calling hello, and this is a response from the hello. Hello actually calls world, but all the dependent spans you can see visualized here in Zipkin, right? That's just a very popular tool to visualize this kind of stuff. All right, so you got node level. How are you doing on time? Doing pretty well? Yeah. Okay, so you got node level versus cluster level logging. Let's go over here. Okay. So I can talk to my Kubernetes cluster, which happens to be in West US, so it takes a little bit, in order to get the pods that are currently running out there. And then I can talk to the pod specifically and get logs for the specific pods. And that will get, that's basically your node level logging. So if the node were to go away, if the pod were to go away and come back on the same node, I think the logs may survive, but the point is that you can't really trust it. You want to harvest those logs from all the nodes into a central place. That's called cluster level logging. And so here you can see the various pods I have, and let's say I want the logs for this pod here. You can grab that. Boom, I can ask for the logs related to a specific pod. And that'll go ahead and spit out everything that was logged to standard out and standard error for that pod for the last few hours, I think. Okay? So, wait a few seconds for that to come back. This is a long ways to West US. Not get logs, just logs. Okay, so you can see you got lots of log type data, and let's go ahead, cancel that, and you can see where is it? There's some requests. It's not seeing it on the screen. There should be some correlation IDs that are being written there. It's not seeing it on the screen. Anyway, I'll show it to you in a different form. But this is, again, logging at the node level. This information is being scraped out by Fluentd and sent to Elasticsearch. Well, let's go ahead and see it in a different form. Okay. Over here, I'm going to run a load test, or actually a web test, that will call my services through the proxy. In this case, I've got the Linkerd proxy, which will then add the context headers. You can do it. Oh, what? That's crazy. Did my network connectivity go down? No, it looks good. Let's try it again. That's odd. This has never failed for me. Try one more time. Either way, let's go here to the next step. So all we have here is, see the, okay. So let's say we want to look for a specific customer's order, right? So they were assigned a specific drone and something happened. You got a phone call saying, my order failed, getting some strange error about a drone. So we want to say, well, you can search your system, your logs. In this case, we're using Postman to send a post request, post query to Elasticsearch. And I'm saying, I want to match with delivery info with this value in it anywhere in there, right? So you're sending that to Elasticsearch. Network connectivity is really strange. It's never failed for me. Very odd. Something weird going on? That seems to be working, right? Very odd. Anyway. Yeah. So anyway, the idea here is that you can search for that, and in the result, you would be able to see all the logs, or the one specific log from that related to delivery information. So that is from the drone service. The drone service knows about drone IDs. So you would get information about logs from the drone service, which would get you the correlation ID for that log. You can pull that out and then use it and say, hey, give me all matches for that correlation ID, and you would get logs across your whole system. Right, and if the previous one failed, this one will probably fail too. But that's the idea. And so you'll get like 40 or 50 different log entries in this case because you're specifying the correlation ID. Then you'll get all of them. Does that make sense? Right? That's how it's supposed to work. Okay. Configuration and secrets. Well, Kubernetes handles configuration pretty easily for you. You just create a config map, which is a collection of name value pairs. You go ahead and configure them with your configuration information as opposed to your secrets. Secrets will go into your secrets. But your configuration information, those name value pairs, will be exposed to your containers as environment variables. So when your container is created, it'll take all those values and stuff them in as environment variables. So that's how you'll be pulling them out. Same with the secrets. Secrets are handled a little more securely, but don't be fooled. It stores those secrets into etcd, which is currently not encrypted. I think it's in beta or so, but it will be encrypted pretty soon. So it's handling it more securely, but it's not encrypted right now, Kubernetes secrets. If you do want encrypted version, Azure Key Vault will encrypt it. I think there's HashiCorp allows some integration where it encrypts your secrets within Kubernetes. Right? Any questions about that? I think that's all I got. So I think we have time for some open discussion now. Is Masashi still around? No. Any questions that were unanswered across between Masashi and my sessions? Yes, right here. Can I get the microphone? Hold on a second, sir. Didn't quite hear that.
So correlation ID and retries, can I see from the logs that which retry is going on? Is there like an automatic thing for that? Like appending like a retry counter to the correlation ID or something like that?
The read-write counter. I think what you're asking is, did the read operation fail or the write operation fail?
First call failed and then something, I'm talking about retrying failed calls, and I would like to see from the logs that, this was the first initial call that failed, and this is the second automatic retry with the same correlation ID.
A retry fail?
Retry, yes.
A retry, right. So the retry is not going to be, it'll be handled by something external to your service, right? So you're responsible for this service, and something is calling you. Every time you're called, you need to go and log as if it were the first time it was called. You don't know it's a retry. right? So if you fail for some reason, something happened within your service and you returned a 500, and let's say it was a retriable operation, and somebody calls you again, you just have to execute again. So there's nothing magical about a retry. So you're going to log again, you're going to take that value out of the context header, and you're going to retry again and log it. And so it'll just show up as another write or another operation, another set of logs. Does that make sense? Yeah. You don't seem very happy about that. We can talk more about it later if you want. Okay. Other questions? Yes, please. Well, hold on one second, please.
Hello. When it comes to the application logs, I see that you said that from Fluent D, you just directly push it to Elasticsearch, right? Fluent D to Elasticsearch.
Yes, that's what we have configured in our
Is
reference.
that okay, or is it that if there are too many nodes and if there are too many Fluent Ds, Elasticsearch might have a bottleneck, so we need to put some middleware in between.
Okay, the question.
And how and when do I decide, do I need a middleware, or Elasticsearch might be able to absorb the shock?
Thank you for the question. I think that there's many different levels to that question. Number one, how do you configure Elasticsearch? Do you want it in its own cluster? How do you want it administered? It's kind of up to you. If you want it directly sent to FluentD, again, it's up to you. If there's nobody else that wants to listen to it, then maybe that's the only source for it. One thing I've heard that people do in the industry is have the log from FluentD sent to some sort of stream, right? You could have it sent to Event Hub, and then Elasticsearch could be one of the listeners to Event Hub. That's especially useful if you have other people caring about logs, right? It's not just the only sync. In our case, we used Elasticsearch as an example of how you would listen to that type of log information.
Yeah, so in your case, did you do some benchmarking that, okay, if you directly put it from FluentD to Elasticsearch, how much was it able to absorb already?
So the question is, how much?
Maybe if I have a mid-size application, I might not want to complicate by putting a streams.
Are you asking about the throughput that we're able to get into
So
Elasticsearch?
Did you measure some sort of throughput in that area?
We were able to get a pretty high throughput into our instance of Elasticsearch. That's not going to be, we're not going to hone on that in our guidance. If you have an Elasticsearch team, you may want to, if you have expertise on that, I would defer to them. What we did is we just simply deployed Elasticsearch in our cluster and depended upon replicas within the cluster to make sure we have some resiliency around that. Some people don't like that, but it seemed to have enough throughput for what we were doing. But there's definitely more advanced ways of configuring that. Okay. Other questions? Right there.
So, how much does it cost to run the application with, for example, 10,000 requests per second?
How much does it cost, as in dollars per month?
Yeah,
Type of cost?
for example, yeah.
Good question. Well, in total, I think it really depends on the number of nodes you have. We tested with, I think, something like 100 nodes. So it's basically, I think, DS3 machines times 50. Plus the master, since we're using ACS instead of AKS. So those are our costs, plus our dependent services. We had 2 instances of Event Hub, which was a couple $100 a month. DocDB or CosmoDB, I think that was also a couple hundred. So not too high, but you can scale out however you want. Yeah. Any other questions? Sir.
Yeah, regarding the monitoring and observability of the system, do you have any insights or heuristics on what to monitor or what things to log? So I'm trying to get to the anti-pattern that I've seen in some teams, that people start to measure and look for only things that are easy to measure and figure out, or try to log everything, which once again makes sense-making really hard from the system. So do you have any insights to share in that domain?
Yeah, sure. Well, first, let's go off of what you get for easily, right? So Linkerd knows about all the service calls and coming in, coming out. So you don't really have to build all that into your system. But what I would look for is when you go into an action, a certain subsystem, I would go ahead and capture the inputs, all the parameters that are coming in. I would go and log those because you know they're coming into your system. Process boundaries, when you're calling something else, I would log that you're leaving your process, things like that. Different error conditions, your exceptions, definitely want to log those. Want to capture them before you leave your process. Yeah, that's generally it. Yeah. Right? Anything else? But yeah, I would look at what you're already getting for free and then adding on top of that. And if you're not using Service Mesh, then you have to probably log more because you're not really seeing a lot of the service calls. All right, anything else? Oh, question back there.
Very short one. So you made this exercise sort of real world. How much effort you used for this?
How much effort did we use to build this? Well, when we build reference implementations, we try to exercise the parts that are interesting, the things that are risky, the things that are hard, but we don't build out the entire thing, right? That would take months and months and years to build out a real system. So we are intentionally incomplete. So a lot of things are not implemented, like all the cancel operations. Like, well, okay, it will get canceled, and there is this theory of compensating transactions, and so it will get called, but we don't need to do that right now. That's something that's pretty academic. You can figure that out. You can do it yourself. So this project took about 3 months, and yeah, it's hard to say when we build something, because when we build something, we write it. We look at it, we hate it, then we rewrite it. We always do that. First pass is something that we never like. If we really liked it, then we did something wrong. We're not very educated because we like our own code. No. We typically will write it and refactor several times. So you guys don't have that luxury a lot of times. That's why we do what we do. Because oftentimes you guys in the industry, you have to ship. And sometimes first time or second time is all you have time for. For us, we take the time to do it a couple times to see if we like it. And we vet it with customers that we work with, say, hey, does this make sense? Do you like this? If it's crazy, then we're back to the drawing board. So it takes us a little longer to do something relatively simple because we just have to iterate. Start from scratch. We do that quite often. Question, yes.
Okay, now we've seen all these PowerPoints with the nice pictures and stuff, but do we have access to the code itself? Can we see it?
Great question.
Somewhere?
I can show you the code here, but we will do better than that. We will give you a link to our GitHub repo once we publish it in the next week. We were hoping to publish it, but then we had to fly here. So we're almost ready. We will send you the decks as well as link to the GitHub repo, which will have the services. I don't know if I mentioned, but we have services implemented in .NET. All the mock services are .NET. The package service is Node, and the ingestion and the scheduler is Java. So we tried to make sure that we showed how to do everything we're talking about, all the logging, all the correlation ID tracking, and everything like that in 3 different platforms. So look forward to that. Yeah, that'll come in your thank you email, right? Yeah. Actually, before we move on, I want to say one thing. I want to make sure that I didn't give the impression that Service Fabric was a bad fit. I'm actually on a dev lead on Service Fabric guidance that will be shipping very soon. What we did with Service Fabric guidance was a different scenario altogether. We have a cloud service application that we ported to Service Fabric, and then we decomposed it to be more microservices-ish. It's a slightly different scenario. That worked out very well. Please look for, if you're looking to do Service Fabric guidance using stateful and stateless services, definitely read that guidance. There's a lot of valuable stuff there that we've included. We've stress tested that app also very much so. But this was a different scenario, and we decided to build this scenario using Kubernetes, mainly because we want to experience and do Docker type of application building. And Docker and Kubernetes seem to be a good fit. I do believe that you can serve and host Docker containers in Service Fabric. I've never tried it myself, though. Okay, just want to.
Yeah, you can. Yeah,
you can.
Yeah, both on Windows and
Yep.
on Linux works
Yep.
works fine. Yeah.
Okay, that's all I want to say.
Yeah.